Hello, and welcome to another episode of The Full Scoop, brought to you by Clue. My name is Oded Ran. I'm co-founder and CEO at Clue Insights. And today, at the last episode for this year, for 2020, I'm really pleased to have with us Mike Vorster. It's not often that we have someone like Mike on the podcast who literally wrote the book on lots of the areas and topics that most people listening are concerned about. Mike, it's fantastic to have you with us.
Odette, a pleasure to be with you and a pleasure to be with everybody out there who's listening to this and watching this. It really is an honor to share thoughts. We're passionate about our business.
Some of you may have not seen Mike. You may have read his book. So just to connect the face to a name, Mike, I think you've got your book next to you. Anyone who's anything in construction management, equipment management, if you do not already have this book, that Mike, you have it next to you there?
Yeah, there's a copy on my desk because I'm going through it very carefully to develop a second version. I don't want to say a second edition because it's going to be very different, but a second version of the book. So it's kind of kicking around on my desk here, but this is what it looks like for now.
Fantastic. So we already have a scoop straight at the beginning. This is version 2 coming up, or second version. So today we're going to be speaking with Mike really about his view about the evolution of construction management and production of construction companies, telematics, and more. And Mike, you really spend your career reviewing this, working with pretty much every single large construction company in the US and beyond. What are your thoughts about where things are going and what has changed dramatically since you first started in this industry?
Well, at my age, since you first started, was shortly after the invention of electricity, right? It's almost impossible to talk about what's changed through my career because so very much has changed. It's just been a complete revolution of information, of sensors, sensor technologies, and a complete revolution in what we can record autonomously as opposed to recording it the old style way with a pencil and paper. That's been the huge revolution.
Right. And you like to speak about construction management and telematics as literally putting someone in the cab. Let's talk a bit about how you view this progression from someone just operating an excavator with no data whatsoever about what they're doing to where we are today.
Originally, when folks started putting sensors and instrumentation on machines, it was done so by the mechanical engineers who wanted to understand the machines in the field on the job performance a whole lot better. What were the power requirements? What were the pressures? What were the speeds? What were the RPMs? What were the loads? And all those sorts of things. So they put what I call a mechanic in the cab, okay? And we started reading fault codes on engines and overheats and overspeeds and so on and so forth. Didn't take us long, and indeed this was the sort of mid-'80s, when we started saying, is there any way we can put a production engineer in the cab? Is there any way we can use these sensors and this intelligence about what the machine is working to not only draw inference on how the machine's doing mechanically, but also to draw inference on the productivity and the production of the machine. And so we started by putting mechanics in the cab, or design engineers or mechanical engineers in the cab. Now we are using that technology to assess the productivity of the machines, to assess the ownership and the utilization of those machines by, if you wish, putting a production engineer in the cab.
And from the change that we've had, because you mentioned, these things and systems have been around for the last 10, 15 years already, right? And including even GPS. I mean, I remember from one of our conversations, you were doing one of the very first GPS experiments on an equipment back in, 17 years ago, right?
I can tell that story because it's a pretty interesting story. And that is that around about 1985, when I first started my academic career at Virginia Tech, I put a proposal into the National Science Foundation, which said, well, we can now produce electronic drawings of the things we want to build. My buddies in mechanical engineering are using these to do machine-controlled lathes to machine shafts and bushings and things like that. What would happen if we used electronic CAD drawings to define an earthworks operation, and then if we put the machines on that drawing and we could direct the machine to produce that cut or that fill? And I put this proposal into National Science Foundation, and they said, yeah, well, I think we should be able to control machines to produce cuts and fills, but how are you going to define the location of that machine? And I said, well, I've got some friends who fly airplanes, and they use Lorraine radio positioning to position their airplanes. And I think we can use that. So they said, and what's the accuracy of that? And that, of course, was the issue, because, we were kind of looking for something we could use to locate the machines so that we could position the machines on this drawing of the cuts and fills we wanted to produce. And of course, GPS came along and solved that problem for us. And so, yep, we've been thinking about position control of machines, if you wish, from the days almost before GPS. Okay, so that's 1985, and that's how quickly things have changed over the time. One almost doesn't think about position as a problem anymore. It's there. Okay.
What are the problems that you think, even though we're in 2020, you and I can have video calls. I can put literally fast internet access in most places in the US. What are the things that you look and say, you know what, but this is still very suboptimal? What are the things you're surprised that 20, 30 years after what you described started, we still are doing a fairly poor job at?
I think we're still doing a fairly poor job at using sensor data to infer production, productivity, and operating status. Okay, we could use sensor data to define, in many ways, fairly accurately, the mechanical status of the machine. What's the RPM on the engine? What's the pressure in a hydraulic system? What's the temperature in the oil? That's mechanical status. And our sensors are fairly good at doing that. And the algorithms we use to take the sensor to infer mechanical status from the sensor data are fairly good and fairly sophisticated. However, production status is something different, all right? Yes, what is the relationship between the pressure in a hydraulic system and the productivity or the production of the machine? Or what is the relationship between the RPMs on the engine and the productivity and the production of the machine? Now, we've got pretty good at measuring the pressure in a suspension struts and saying, that's the load on the machine. And so can we combine the time the machine spends within 3 meters of a loading unit and the fact that pressure is growing in the suspension strut? Can we write an algorithm that reasonably infers the machine is being loaded? I think we can. Can we write an algorithm which says the machine is 10 meters from a loading unit, the velocity is 0, the pressure in the suspension struts is not growing, the machine is waiting to be loaded? We can gather all those sensor outputs. Can we write the algorithms that enable us to, with reasonable accuracy, infer what's going on in the life of that machine from a production point of view? That's where I think is the current frontier and the new frontier, if you wish.
Have you seen any company or any future-looking company, construction company, already starting to do these things, or is this still people are still spending most of their time battling these battles of maintenance and downtime, and the same type of battles that you've seen throughout your career?
Well, yeah, the use of sensors and sensor data and getting really involved in and using them to put a production engineer in the cab, that art is very badly developed. We've done a couple of research studies on it. and found huge opportunities for improvement. A couple of companies have embraced that and affected huge opportunities. The mining industry in general has gone a long, long way, but the general construction, the infrastructure construction industry has a lot still to learn from the mining industry. Okay. Bearing in mind that, there are not a lot of construction operations that run from 7 a.m. to 5 p.m. In mining, you run essentially the same operation from 7 a.m. to 5 p.m. So you really can optimize it and get it to be and fine tune it. But in infrastructure construction, there's so much out of sequence work, there's so much delayed work, there's so much rework, there's so much change in position that perhaps the fineness of the productivity and production studies in the classic work study sense, perhaps that's another order of magnitude for the performance improvements we can effect by just making things more simple, more routine.
Right. So I'm going to ask you something a bit difficult. Lots of the equipment managers and fleet managers that we speak with at Clue, they have a very difficult job. They're very busy, to say the least. So even when we recommend to them to get your book, 250 pages long, and it takes time to concentrate, I worry sometimes that they're not getting to it. So if you had to summarize the 10 Mike Vorster commandments to the equipment manager or the fleet manager, it could be fewer than 10, as many as you want. What would they be? What would be the key things he said? You know what? You might have been doing your job for 15 years. Please make sure you are abiding by these X commandments I'll share with you.
Okay. Yeah, it is, in my opinion, a lot less than 10. And I think I'll cut it down to 4. All right. How about that? I think one of the things, and maybe 5, I think one of the things that I would tell them to do, and this is very controversial, and in my career in field construction, I won't say it got me into trouble, but it was very controversial style that I had in my field construction career. And that is, I believed that cost was the end result of performance in the field. And that cost was the end result of all your decisions and that sort of thing. And that you wanted to not attack cost, but attack the causes of cost. So I think commandment number 1 or recommendation number 1 is don't waste too much time mulling about cost. Spend your time looking at the things that caused those costs. And the byword there is, hey, you can't manage money you've already spent. Okay. So focus on the causes of cost.
Let's make this actionable. So what does it mean to me right now? What should I do differently when you say causes of costs?
Well, those are then numbers 2, 3, and 4. All right.
Okay. These are linked commandments. Okay, cool.
Linked command, because I think there are some lead indicators of cost. And in my world, there is absolutely no doubt that utilization is a lead indicator of cost. And here the byword is that a machine is only an asset when it's working. All other times it's a liability. Okay. So if you get utilization right, the chances are you're going to get the owning cost right. And the more utilization you can get, the more working hours you can get, the more production you can get out of a machine, the cheaper, the lower you're going to get the unit rate from an owning the asset point of view. So if you're going to attack the causes of cost, the first cause of cost to attack, or one of the causes of cost to attack, is utilization. The second cause of cost in my book that you need, in my world, that you need to attack, because it's not in the book, current book, it's going to be in the second edition of the book. The second area that you've got to attack is reliability. Every down event is a cost event. And if you can reduce the number of down events not necessarily the duration of the down events, but the number of down events, you are going to reduce the number of cost events. And so you're going to really attack the causes of your operating cost, your repair parts and labor costs, because every down event is going to involve some repair parts and labor. And if you've got a lot of little ones, it's only a matter of time until you get a few very big ones. And so if you can manage reliability and if you can get your maintenance and your condition-based maintenance and your inspection programs and your operator training programs and the way you apply the machine, if they can all be focused on eliminating down events. And I do believe that you can eliminate down events to pretty close to zero. Remember the old days when we said we couldn't reduce accident frequency rates in construction to pretty close to zero? Well, look what we've done with safety in construction. I think we can do something very similar with reliability in our equipment.
So that's interesting because there are companies that we see that the first problem is they just don't measure it, right? You ask them how many down events you actually had in the last 30 days. 30 days they probably remember, it's fresh in the mind, but they don't measure it, they don't write it down, they don't document it, not digitized. And that's one thing we see at Clue. But he's saying after you hit that prerequisite, you should know what percentage of your time and money you spend. And for anyone who's listening and they want to benchmark to know, are they getting an A plus or they are F minus? What would you say is good enough, top quartile in terms of down events, both in terms of as percentage of total events or maybe as percentage of money spent, whatever KPI you feel is the correct way to measure it?
I really don't have enough data to talk about benchmark values for reliability because, as you say, a lot of companies don't measure it. The companies that I work with, we're only just starting, and we're really learning about down events. The interesting thing about down events is they're sort of binary. They either happen or they don't. And you're not fussing with recording the duration of a down event. You're just recording the fact that somebody got on a radio, somebody got communicated with somebody and said, this machine was supposed to be working and it's gone down. Don't fuss about the duration. This machine has caused this disruptive event in the smooth flow of the construction operations, right? With regards to benchmarks, with regards to cost, I have seen companies that are spending less than 15, something like about 10 cents in every dollar that they spend on repair and maintenance, on repair after failure. In other words, a repair, in my world, a repair, you have to have a failure before you can have a repair. If you don't have a failure, it's a maintenance action. Maintenance actions are designed to preempt failures. Repairs are designed to fix failures, right? So 10 to 15 cents in the dollar would be, I think, pretty damn very, very good in terms of 15 cents in the dollar that you're spending on repairs compared to your total spend on repair, on maintenance and repairs, right? Because you're then spending 85 cents on prevention and 15 cents on repairs. Okay. That would be a very good level to arrive at.
Perfect. That I'm sure that's very helpful to anyone who was looking for some numbers around that. Great. So that was really one thing around repair and utilization.
Okay, number three,
reliability.
Number four, because the third area in which you can attack cost is the average age of your fleet. All right. We do know that there's a relationship between the cost of owning and operating a machine and the age of that machine. We do know if you keep that machine to shorter period, you're going to spend a lot of money per dollar per hour on the amortization, on the depreciation, on the loss in value of that machine. If you keep it too long, you're going to be selling your soul over the parts counter on repairs and parts and labor. And so we do know that there's a point, an optimum ownership period, or whatever you want to call it, where you can minimize the total of the owning and operating costs of the machines. And I think that we really need to get very much better at managing our build, replace decision around that point. Because if we do that, then we'll know we're not throwing good money after bad. Okay. It just breaks my heart to see companies spend a lot of money on machines when they're worn out. They're done. They've served their purpose. They've lived their optimum ownership period, and it's now just throwing good money after bad. And if you can stop yourself from throwing good money after bad, or if you can have the knowledge that enables you to take decisions that stop you from throwing good money after bad, I think you'll save yourself a lot of money, or attack the causes of cost, right? If I say rule number one is attack the causes of cost, and I'll say, and attack the causes of cost by focusing on three things. First one is focus on utilization, because a machine is only an asset when it's producing work.
Mm-hmm.
Attack the cost which you incur when the machine is sitting predominantly off the site. All right. Attack the causes of cost that arise when the machine is just breaking down too often. Attack the causes of cost that arise when the machine's too old. There are three simple ones, right?
Fantastic.
Now that's a lifetime. It'd take you a lifetime to do those things, all right? But there it is.
And before we get from you a bit of a preview into the update of the book you're working on, let's talk a bit about the work that you've been doing a lot with companies. Just to describe it in terms of type of workshops, how does it work? A company would contact you, and then you would sit with them for a whole week with the owners and the executive team, or what would a typical engagement be? And I guess some people listening wondering, if I want to get you right now to come and help our company get from F to A, do you still do these things?
Very much less I did, unfortunately, than I used to, because the passage of time is such that a 4 or 5 day, 8 hours a day workshop is pretty heavy sledding. Because for a number of years, I did once or twice a year a 5-day in residence equipment management workshop. Did them at the Georgia Tech Hotel and Conference Center. They do such a good job of hosting the workshop. And right now, of course, with COVID and where we are, I'm doing a couple of workshops and continue to do them on Zoom and online, and gathering some quite good experience on how to do that, and how to do that in a way which keeps up the sort of involvement and attention of folk who are studying the material or listening to what I have to say on Zoom or remotely. And there are some techniques that have kind of come to the fore to do that. So yes, to a very much lesser extent that I used to, I am still doing workshops in the fleet management things. Okay. But let me say this about those workshops, and I've just kind of had a conversation with a company that I'm working with on the subject, and that is that my definition of equipment management has got very, very little to do with oil and grease and nuts and bolts and lefty-loosey, righty-tighty, and with shops and mechanics and filters and bearings and bushings and those sorts of things. My definition of equipment management has a lot more to do with the dollars and cents, all right, and the repairable replace decision. And so what works very, very well, and what I would recommend anybody does who enters this sort of arena, is make sure that you include the folk who focus on oil and grease and lefty-loosey, righty-tighty, and the folk who focus on dollars and cents and the lease decision and the borrow decision and the investment decision and the capex decision and the return on investment decision, and also include the folk who focus on the pulling and pushing aspects and the production and the productivity of the machines. Okay. And so to me, in the best workshops I've ever run, This was the situation in many of the Atlanta workshops. The class was made up of about a third of the folk whose genes were all about and whose skills and knowledge were all about oil and grease, and a third of the folk whose genes were all about dollars and cents and investments and return on investments, and about a third of the folk whose contribution was and whose genes were all about pulling and pushing and producing completed work. Develop a common language and a common understanding about what the hang equipment is all about, okay? And that's really, I think, the workshops I've done have been able to achieve.
Right. And translating that into really from a system perspective, I guess what you're saying is that to achieve the optimization, you cannot just look at the equipment managers, just the operation people, or just the finance people. You literally have to connect them all to work and speak the same language, which historically and from the experience we've had in the last year in Clue, it means a real change in shift, right? In thinking. It takes strategic thinking from the owners or the president to want to bring it together. Otherwise, they would create silos within their organizations, and it'll be very difficult to achieve this level of optimization. Is that how you view the world?
Yeah, and you mentioned exactly the right word, and that is sort of strategic thinking on the subject. And remember that a whole lot of tactical decisions bolted end on end do not make a strategy. Okay, and you need an overarching strategy across your company as to how you're going to manage this investment in your equipment assets and how you're going to keep them as assets, not liabilities. And remember that for many heavy civil infrastructure companies, about a third of the left-hand side of the balance sheet is represented by net PPE, right?
Right. So a third of construction companies' balance sheet will be in equipment, or like I love your quote from earlier. If the equipment is working, it's an asset, but if it's not working, it's a liability, right? So
which is to the other side of the balance sheet in a heartbeat.
Yeah.
And there's another thing that I think that I would like to share with our listeners, and that is that where would your company be if the only person who was interested in cost was the financial manager, the CFO? The only person who was interested in production was the production manager, or heaven forbid, the only person who was interested in safety was the safety manager.
Right.
We're all involved in all those things, and the only person if the only person in your business who's interested in equipment is the equipment manager, you're on a beating to nowhere.
Right.
Because we're all involved in equipment management one way or the other. Okay.
I love the analogy to safety because you're right. No one in 2020 would dare think that safety is only the responsibility. Everyone should be losing sleep on that or caring about that, right? So
yes, and the only person who's good companies, in fact, have their safety manager as the champion of the cause, as the standard bearer, as the lighthouse towards which everybody can travel as they do this better and better and better. And I think your equipment manager is the same.
Right.
If the only person in your business that was interested in people was the personnel manager, wait a bit, nothing would work. Okay?
Exactly.
And the same thing with equipment. We're all involved in it one way or the other. And then before I stop this little theme, the person who is more involved in equipment management than anybody else in your business is, of course, the person who sits in the seat. Because there's nobody who's responsible 8 hours a day for the management of a piece of construction equipment. More. There's nobody except for the operator.
Right. With that in mind, I'd want to spend the last few minutes giving a bit of a teaser about the chapter you're working on now and the update you're working on now. I know it's still a work in progress, but give us a bit of a teaser to what you're working on. And I'm thinking in 2021 we'll do this again once the chapter and the book is ready for the next stage. But what do you tell us a bit more?
Well, that first thing is thank you very much for your contribution to my thinking and for your contribution to chapter 12, all right, and many other aspects of the book. Because, what I say to folk is that I learn about things because I kind of rub shoulders with bright folk who do it and who think about it, and then I learn from them, and I just have maybe a talent to synthesize other people's thinking. So first of all, thank you. With regards to chapter 12, this is where I am talking about utilization of your assets. What percentage of the time does the machine live as an asset, and then whatever's left, it stays over there as a liability? And from an equipment and equipment management point of view, utilization really is what percentage of the machine's life is it able to be utilized? Is it on site and able to work? How much of it then is utilized by the folk who are running the operations is an issue which is hugely controversial, but which is by and large out of the control of the equipment manager, all right, and out of the equipment management function. And of course, as we get to this, and as I was putting this chapter together, I said, you can't duck and pretend that telematics and onboard sensors and using onboard sensors to infer the production and productivity of the machines and the operating status of the machines doesn't exist. And so I've kind of had to revisit some of the original work that we did in the late 80s and early 90s on using sensors to infer production and productivity status of the machines. And so chapter 12 and section 12.1 specifically draws a difference between what I call the operational status of the machine. Is it on site? Is it able to work? Is it being used? And then the sensor status of the machine. Is there pressure in the hydraulic system? Is the engine running? Are the suspension struts loaded? Okay. And what we can infer from the sensor status of the machine to help us better understand the operational status of the machine. So there's a teaser for you, right?
That's fantastic. And for anyone who wants to learn more, it's very easy. There's a website called Google, and you can put Mike's name, Mike Vorster, and Construction Equipment Management, and find his website, CEMPcentral.com, correct?
Yep.
Yeah, and get the information there. And we always finish with a question that is, if I now give you as a Christmas gift the ability to operate any asset, any heavy construction asset that you want to operate and have a field day with it, which one would it be for you?
A buddy of mine sent me a video the other day of an excavator. And this excavator, we see these funny videos, which I actually don't like very much because frequently they show very unsafe operations. And that upsets me, that we sort of glorify unsafe operations. And this excavator, the operator was loading it up onto the truck to haul it away. And it was taken somewhere, it looked to me like in the Philippines. And when the excavator was loaded on the machine, sort of a 10 or 11-year-old young boy got out of the machine and everybody went, "Whoa, look at that." And I sent it back to him and I said, well, that wasn't very funny because I was about that age when I started operating equipment. Without a doubt, my favorite machine is the motor scraper, all right?
All right.
Because motor scrapers are incredibly busy. If you think that a motor scraper has got to complete, in order to make money, a motor scraper has got to complete about 45, 55 cycles an hour. What are you doing in those 50 cycles an hour? You're loading it, you're hauling it, you're dumping it, you're returning it. You're constantly busy. And I've done a 4-hour before lunch shift or a 5-hour before lunch shift on a motor scraper. And the guys, I see the other guys parking for lunch. And I say, wait a bit, we've only just started. And so without a doubt, in my world, motor scrapers are the single most fascinating things to operate.
This is awesome. I'm gonna make sure we will send this to every operator of motor scraper that he's included to wear that as a badge of honor.
There are not a lot of 78-year-olds who spend their time watching Southern California earth movers on YouTube.
I picture every dozer operator that ever listened to you is like, I can't believe that he didn't choose my asset. But anyway.
No, it's motor scrapers. They just keep you way too busy doing stuff.
Fantastic. So, Mike, it's been an absolute pleasure having you on the Full Scoop, and of course, working with you. I want to wish you and your family and everyone you work with and everyone who's listening to the show a very Merry Christmas, Happy Holiday Season, Happy New Year, and I hope you return to a 2021 that finds you peaceful and at ease and happy. Thank you so much for listening to the Full Scope in 2020, and we will see all of you back in 2021. Thank you very much again, Mike.
Thank you, Edith. Thank you, and greetings to everybody.